Hello guys, hope you are all doing well. In this video I'm going to explain this problem of the day from Geeks for Geeks, and the today's problem is largest prime factor. Let's get started. Given a number n, the task is to find the largest prime factor of that number. Here they are asking about largest prime factor. Now what is this largest prime factor? It is consisting of three words: largest prime factor. We'll start with factor. What is factor? So if for any number a, if b divides it completely, means remainder is 0, then b is factor of a. So clearly any numbers divide other number is a factor of that number. And if it is a prime number, if the number that is dividing is prime number, then it is a prime factor. And we have to tell the largest prime factor, means there should not exist any other largest prime factor which is dividing this number. Let's take example 24. What is the largest prime factor for this 24? Let's write down all its factors. Obviously one will be its factor, one is factor of every number. Now 2 divides it, yes, 2 divides it 12 times. Now is 3 divides it, yes, 3 divides it 8 times. 4 divides it 6 times, 6 divides it 4 times, then 8 divides it 3 times, 12 divides it 2 times, 24 divides it 1 time. All these are the factors of 24. So we have to find the largest prime factor. So we'll start searching for the prime factor from the back. Is 24 is the largest prime factor? No, it is not a prime number. Then how can it become a largest prime factor? It is not a prime number, it is divisible by 2. So what, I hope that you must be knowing what is prime number. Prime number is that number which has only two factors, one and itself. Only two number divides it, one and itself. But there is, for 24 there is other number other than 1 and 24, that is 2, that divides it, so it will not be a prime number, and neither it will be a largest prime factor of 24. Similarly for 12, it is not a prime number. 8 is also not a prime number. 6 is also not a prime number, and 4 is also not a prime number. But 3 is a prime number, and 3 also comes in the list of the factors of 24, and it is the largest as we got it by searching from the back. So 3 is the largest prime factor of 24. So how we are going to find this largest prime factor? Through our code. What will be our approach? Let's find out. This is pretty simple problem. If you know a fact, mathematical fact, that is, let's take 24. I will take this number, whichever number is given to me, and I will start dividing it with 2. And I will tell in a second why I am doing this. I will divide it by 2 till it is divisible by 2. I will divide it, I will get 12. Again I will check the quotient which I am getting is again divisible by 2 or not, and I will keep on repeating this till the number which I get is now no more divisible by 2. So is 12 divisible by 2? Yes, it is. And 6 times I will divide it, and its result 6. Is it divisible by 2? Yes, it is. 3 times, so I will write it. Now 3 is not divisible by 2, so I will stop here. I will not divide it by 2. I will move on to the next number, 3. Is 3 is divisible by 3? Yes, and 1 times. So whenever I will get this 1, and the last number, the number from which I got this 1 will be the largest prime factor. This is a mathematical property that if we keep on dividing it with 2, then all the factors of 2 and all other numbers in between this prime number and other prime numbers will be removed, and it will only be divisible by any other next prime number. So in this way this is definitely going to be a prime number. The number which divides the result will definitely be a prime number, because if I am dividing it by 2, then it will I'm removing, actually removing 2. If I'm again dividing it by 2, then actually I am removing 4 from it, and again dividing it, I will removing 8 from it. In this way I am removing all other non-prime factors from it. So at the end it will only be divisible by next any other next prime number, and the last number which divides it, and I'm getting here 1, will be the largest prime number. Definitely it is a prime number, and it is as it is dividing at last, so it will be largest. Now let's do the same for any other number. Let's try with 100. I will again follow the same procedure. I will divide it by 2, I will get 50. Then again I will get 25. Now it is not divisible by 2. I will check, is it divisible by 3? No, it is not. Is it divisible by 4? It is not. 5? Yes, it is. So you see, definitely it is going to be divisible by any other next prime number. So it divides it, yes, 5 times. Now 5, is it divisible by 5? Yes, it is, one time. So we got one. We'll stop here, and the last number which divides it will be our answer. So for 100, 5 is the largest prime factor of 100. In this way we'll code it. Now I'm going to code it as I have explained. So I'm going to use here a for loop for getting these number 2, 3, 4, 5. So for, I'll start with 2, as here I will start with 2. So 2, I will move this for loop till that number. In case of prime number, we have to divide it till that number. In case this n is a prime number, it will not get divisible by any other number, it will get divisible by only itself. Here I will increase my I, and here I will check if that n is divisible by I. If it is, then I will keep on dividing it by this number I. I will divide n. So for repetition I am using here a while loop, and at the same time I will also change n, and n will be n divided by I. And here I will check if at the end n becomes 1, so the number I that was dividing it is our answer, it is largest prime factor. So return I. So this is the code, only this much code. Now let's try to run it. Yes, 17, it is showing 17 for input 17, it is showing output as 17. Let's try to submit it. Yes, all the test cases are passed, it is working absolutely fine. Hope you understood the concept, and I will see you in the next video. Till then, bye bye, take care.